we're in agreement that life is programmed at the highest, beyond what computer programmers can program. That's how well life is programmed. All 29 scientists agreed with that, and that these people included mathematicians, every type of scientist that you might imagine could be applicable. Mathematicians, linguists, because DNA has a language, nuclear physicists, computer scientists, geneticists, molecular biologists, cell organism biologists. Every field you could imagine was there. And it included yuck, you know what yuck is, right? And it included OEC, right? You know OEC? And it included TE, and it included F. There were evolutionists there who agreed that biological information cannot arise by trial and error. It takes intelligence to create information and information systems. So here's what the editors, I'm one of the editors. This is a great quote. We say what we want to say, but this is our opinion. This is by far the most rigorous and in-depth examination of the sufficiency of neo-Darwinian theory. Neo-Darwinian theory is just updated version of Darwinian natural selection. Never have so many well-credentialed scientists representing so many disciplines united so effectively to look beyond the standard mutation selection paradigm. So that's I believe, a truthful statement. And I believe this book sounds the death knell of neo-Darwinian theory. That doesn't mean evolution is wrong, but it means that the almost universally accepted paradigm of how evolution happens is wrong. I'm going to skip over these because we talked more broadly. These are some of the papers. This is a paper by a colleague of mine. He actually studied DNA repeats and repeats in computer programs. And the computer programs and the genome look identical in their patterns. Same architectural patterns. No other, we looked at music, we looked at human literature, we looked at everything else, but only computer programs have the same patterns as the genome. And we found that there are overlapping codes in the genome. In other words, the same piece of DNA codes a different message if you read it one way versus reading it another way. And that's happening massively. We asked computer scientists, could you make overlapping code with two different messages? And they said, never. One of the papers shows that the nature of most beneficial mutations is there's very, very subtle effect, and they can't be selected because they're too subtle. And so it's basically saying it's really hard to capture, even if when a beneficial mutation does happen, which is exceedingly rare, it's very hard to capture it through natural selection. And we did computational experiments that show there's a net loss of genetic information no matter how intense the selection we simulate is. And that, let's see, I think we're okay on time. Speaking of time, there's a waiting time problem. And it's really an intriguing problem. Here's the problem. You have to change an ape into a human being in 6 million years. You have to create a lot of new information to create a person from an ape, because you have to explain intelligence and music and science and all that. And if you're a Christian, explain the soul. And it's hard to, a few mutations won't do that. So you need to create tons of information we can't even conceive of. What type of genetic code gives us consciousness? What type of AST, C's, and G programming will create an unconscious thing to make it conscious? So you have to create all that information in a blink of an eye in terms of evolutionary time. So this is the paper that we published just a year ago, and I'm really excited about it. This is the link, but if you just Google waiting time problem and hominin, it'll pop right up. It's published in Theoretical Biology and Medical Modeling, and there have been previous papers. I think we nailed it. We have the best characterization and quantification of the waiting time problem. And this paper, this is a pretty minor journal, but there have been 5,000 downloads in the first year, which is maybe the most highly accessed paper that journals have. So this generated a lot of interest because our argument is extremely strong. The waiting time problem, I'm just here, I give a little history of it. The bottom line is that Behe recognized it, and there were some other people who could see it coming. Behe recognized the full magnitude of the waiting time problem, and then people have tried to, some people have supported his work, other people have attacked his work. But then now we've proven by simulation, numerical simulation experiments, just last year, that Behe was right and that the waiting time problem is profound. What is the waiting time problem? Well, I'm covering a lot of ground. I'm just trying to introduce you to lots of different evidence for a creation perspective. So excuse me if I kind of fast forward through this, but you can read the paper. It's easy to download. The bottom line is, down here we have string length. So a gene is a string of 50,000 letters on average. Human gene is about 50,000 letters long. It's a long text message. And we're only going to look at strings of 2. So a string of 2 would be like 2 nucleotides, like A and T. A string of 3, a string of 4, up to a string of 8. So these are what you could call genetic words. These are the shortest possible genetic words. And so we're looking at how long it takes to create a string of a given length. And here's your time scale. And so let's see, it starts out with a time of 0, and then it goes up to 5 billion, and 10 billion, and then 15 billion. So it's counting in billions. That's years. So before I show you any data, you're probably realizing, gee, you're counting in billions of years. And we're talking about strings this long. So that's exactly the point. Let's look at a string of 1. Is a string of 1 a string? Not really. But let's just, how long does it take, if you're waiting in a small population, a population of 10,000, which is the assumed population size of the ape population that was evolving into man. 10,000 people in that population. That was the effective population number. Okay, so if you're waiting in that whole population, not for one of them, but anywhere in that population, you're waiting for a mutation to arise. You're waiting for a specific mutation, let's say an A, to turn into a T. You're just asking for one specific nucleotide substitution. That's all you're asking. It's like having a text and then changing one letter from one alphabet letter to another. That's all you're waiting for. Well, it turns out, even though there's a high mutation rate per genome, the mutation rate is extremely low for any given letter. So how long does it take to get one letter, get it amplified to a population? Everyone's carrying that gene. Let's see if I can press the right button. For a hominid population, a string of 1 requires 1.5 million years, and that's assuming all optimal settings, like really strong selection pressure, 50% elimination of the unfit, and lots of, this is the best case scenario. It still took 1.5 million years to wait for a specific mutation to happen and go to fixation in a hominid population. We simulate this in a computer, so it's like simulating blackjack or a poker game. It's a real reflection of reality. Let's look at what a string of 2 requires. A string of 2 would be like AT, 84 million years waiting time on average, 25 replicates. 84 million years. How long do we have to do the ape to man? 6 million. So as soon as you need to make a string of 2, you need 2. If you need 2 mutations, not 1, before you can, and you don't get to reward it until both are present, right? It's like you're waiting to get a completed word, like W is not a word, but WE is a word, right? We're waiting for a word of 2 letters. It takes more time than the ape to man scenario allows. What if we need a string of 3? It goes up to 376 million years, and 1.2 billion years for a string of 4, for a string of 5, 2.3. String of 6, basically we're talking about the age of the Earth from an old Earth perspective. basically, the Earth wasn't habitable until that long ago. That's for a letter, a word of string letter, a word of 6 letters. And then if we jump up to 8 letters, we exceed the time since the Big Bang. Well, 8 letters doesn't mean much. Actually, each nucleotide you need 3 nucleotides to equal enough of an English letter. So this is only equivalent to, another way to say it is, this is the same as only changing 3 amino acids in more time than the Big Bang. So the waiting time problem is really profound, and there is not an adequate response to it. Okay, now we're going from, we talked about the fossil record, which I fast forwarded through. We talked about the biological information problem, which is this huge volume of papers, which I tried to summarize briefly. Now we're going to talk about genetic entropy, which is not my favorite subject because it's very tragic. It's about the fall. It's the fact that we're dying. We're all dying personally, and we're dying collectively. Is that good news? No, but it's true. And actually, for a Christian, it's okay because there's heaven. No, the knowledge that we're dying is not a problem. The fact that our bodies are degenerating is not a problem because there's something better. Okay, so you can go to the website to learn more about it. Bottom line is bad mutations accumulate. You can't select them away as fast as they accumulate. If you keep adding misspellings to a text, and you are adding them faster than you can edit them out, eventually your text is going to be gibberish. And that means because you can't stop most bad mutations from accumulating, only the worst mutations are selected away, is therefore down, not up. Because even if there's a few beneficials in there, there's not enough beneficials to outweigh the genetic load. And so evolution needs to go the wrong way unless there's another mechanism. If you want to invoke some other evolutionary mechanism, like God helping it along, that's fine. But left to itself, mutation and selection cannot improve a genome. It will cause a genome to rust out. And the evidence for it is very, very, very strong. Very, very strong. Can you hear me there? Okay. Here's the book. I've left a copy for the club and for the university. It's easily available at other sources. This is the picture. I think a picture can be worth 1,000 words. That's me. And my life is based upon orderly arrangement of certain nucleotides, A's, T's, C's, and G's. And I am dying because my genome is falling apart. There's about 3 mutations every cell division in the human body. And I need God. I need a living God to restore me. That's the image is saying, that's what I'm trying to communicate. There are 4 natural miracles. If you're an atheist, you believe the universe made itself, then life made itself. Then life improved itself indefinitely until man became a spontaneous creation through the mutation selection process. Those are the 4 pillars of atheism. If you're an atheist, you have to believe all 4 of those absolutely are true. If you take down any one of those, the whole thing comes down. It's like a table with 4 legs. If any one of those requires intelligence or design, you can't rationally be an atheist. But all 4 can be disproved, which is astounding. And the one that we're going to disprove is this one here, tonight. This simple. Once you get your first bacteria somehow miraculously arise spontaneously in the original organic soup before life, then it's just a matter of it's certain that that's going to evolve into an intelligent being, right? No, not right. Okay, there are 2 worldviews. We are naturally going down, or we are naturally going up. And so the first part of the genetic, GE stands for, does not stand for General Electric, it stands for genetic, no, it doesn't stand for genetic engineering, it stands for genetic entropy. Okay, part one, the biblical view. We're going to go real fast. Everything is wearing out and dying. We're dying people in a dying world. Is that true? Amen? And it's because of the fall. So here's 1 Peter. All flesh is as grass, and all the glory of man is the flower of the grass. The grass withers and its flower fades away, but the word of the Lord endures forever. This is saying that not just that we ourselves are flowers quickly fading. For those of you who are over 50, can I get an amen to that? So, Hebrews 1, you, Lord, in the beginning laid the foundation of the earth, and the heavens are the work of your hands. They will perish, but you remain, and they will all grow old like a garment, like a cloak. You will fold them up, and they will be changed. The universe itself is wearing out. It is running down. That is the biblical view, and we're waiting for Christ to rescue us from this body of sin and death and decay. Let's just look at some biblical data that I bet you don't even know exists. Do you know there's scientific data in the Bible? It's really interesting. All you have to do is go through the Bible and figure out how long people lived. And you get a really interesting pattern. Here's the longevity of the Noah and his descendants. So this is how long Noah lived, 950 years old. This is how old his son lived, Shem. Poor guy died at 600. And so here we have Abraham, Isaac, and Jacob. And then here we have David. And this is the average life expectancy of a Roman during the time of Jesus. So there's a pattern there. It's a biological decay curve. And as a geneticist, I've been studying genetic entropy, which seems irrefutable. This makes a lot of sense to me. And it's straight from the Bible. So part two, scientific view of degeneration. You know, all physicists know that energy degenerates and it dissipates. So you start out with useful energy, which is compact and tight, and you let the gasoline burn and it becomes heat and then radiates away. So that's biolistic. What am I trying to say? Can't even think of it. Thermodynamics. Second law of thermodynamics is what I was trying to say. Basically, we know energy spontaneously degenerates. Physical order also. If you stop taking care of your house or your car, you know that it will just run down and break down. It turns out that information also decays. Play the whisper game, or look at the chain of command, and find out that information decays. And living organisms, obviously all living organisms die. It turns out that the thing that's driving that is mutation accumulation. And lastly, populations. Because individuals are accumulating mutations, so do populations. So logically, populations should also go extinct. Entropy means that everything is degenerating apart from one special ingredient, intelligent intervention. If you take care of your car, you can slow down entropy. And if you're really smart, you could maybe improve your car. But no intelligence is allowed if you're a strict Darwinist. So now a personal view of degeneration. We all really enjoy hearing about this. Mutations are killing us. Typos in our DNA code molecular mistakes. Entropy is entropy working at the molecular level. 3 cell divisions, 3 mutations per cell division. This mutational degeneration in our own genes is called genetic entropy. Michael Lynch, probably the top population geneticist, best known population geneticist in the world today, published in his inaugural paper in Proceedings of the National Academy of Science when he was initiated into that elite organization. This is what he purported in his paper. He said the average cell in a 15-year-old has up to 6,000 cell mutations that weren't there when they were conceived. So for you young people, you're mutants. Wait a minute, if you're my age, you have over 40,000 mutations per cell that have arisen since you were conceived. That's his data. And he acknowledges that mutations are the primary cause of aging and death. So he concludes little potential for substantially increasing upper limits of human lifespan because we're all rusting out. And so look in the mirror, and over a few years you'll see that what makes us us is that all our nucleotides, all our genetic information is in place. If you start to scramble the information of a genome, you start to break down of the human body. And so this is what I kind of see when I go to the mirror every morning, is I see the old guy whose DNA is falling apart. But it's okay because I'm a Christian. Basically, this type of genetic entropy is indisputable. This is a fact. But if this is true, then there are consequences for the population as well. So we're going to jump to populations. The population view of degeneration is as follows. Life forms are wearing out like a garment, just like the Bible says. Entropy does not just cause the decay and death of individuals. Mutations are transmitted from parent to child. This can cause a whole species to age and die. So, happily, the mutation rate in our reproductive cells is vastly lower than in our somatic cells. I would argue that's by design. The reproductive cells are put aside, kind of in the freezer, until we need them. And because of that, we only have about 100 mutations per reproduction, that is per baby. A baby has about 100 mutations that mom and dad didn't have. So the baby inherits all the mutations from previous generations and adds another 100, and then when they grow up, they'll pass it on to their children. Every generation is always 100 more mutations, more mutant than their parents. That's what's happening. So we've accumulated in our germline, tens of thousands, germline is our reproductive cells, tens of thousands of bad mutations, and we see some of them right away. Like 2 to 3% of babies have visible birth defects. And there are thousands of known catalog genetic diseases that reflect this type of mutation, but most mutations are nearly invisible, are invisible. Like, we're all, like, okay, let me give you, I have 40,000 new mutations in my body. Every cell has 40,000 new mutations that weren't there when I was conceived. So take all the mutations that my progenitors gave me and now add to every cell in me 40,000 more. Why am I alive? It's because most typographical errors in the DNA are so subtle that they reduce fitness by only like 1 part in a million. And so, fortunately, mutations don't destroy us, but unfortunately, they're so subtle that natural selection can't eliminate them. And so they're unstoppable, like rust is unstoppable in your car. Okay, here's 3 geneticists, really highly distinguished geneticists, who acknowledge that the human genome is degenerating. Dr. Kondrashov was a geneticist at Cornell, and I knew him a little bit, talked to him, asked him about this question. He said, no human geneticist doubts man is degenerating. Dr. Crow, who actually was his mentor, so he's older, he died now, we're inferior to cavemen. Fitness is declining 1 to 3% per generation. He's an evolutionist, he's a committed evolutionist. And Dr. Lynch, the one I just mentioned, we're degenerating at about 1 to 5% per generation. So, I mean, at first if I tell you the human race is degenerating and always has been, you go, well, he's nuts. But you see, what I'm saying is actually in sync with what other population geneticists acknowledge but don't proclaim. Now, they would all say if we could just increase natural selection, that is, if we could let more of you unfit people die before you reproduce, we could maybe overcome this problem. But all our studies, all our numerical simulations show, no matter how ruthless selection is, you can't stop the accumulation of these mutations. Okay, here's what Michael Lynch says at the end of his paper. He expects significant incapacitation at the morphological, physiological, and neurobiological levels for the human race. That's a cheerful thought. Without Christ, there would be no hope. Our hope is in heaven. The sooner we realize that, the more we can put everything in perspective. And they argue that if we have more death, that would solve it. It's clear from our analysis that no matter, even if you shut down all the hospitals, stop taking care of old people, stop immunizing young people, it's not enough to stop the accumulation. So just reminding you of the history of, according to the Bible, it's totally consistent with genetic entropy at the population level. Each generation has more mutations than the last generation. Okay, now going on, according to Darwin, somehow all that's not a problem. Darwinists claim that natural selection reverses entropy. Everybody agrees that mutations are entropic, that is, they destroy information. But there's a few good ones, and they say, look, beneficial mutations happen. They're exceedingly rare, but they happen. Furthermore, selection happens, right? Yes, it does happen. And change happens. Yes, change happens, mostly down, but change happens. So yes, beneficials happen, selection happens, and some bad mutations are selected away. But what we're going to see is the mutations that are beneficial are too rare. The bad mutations are only the worst ones are selected away. And so change happens, but in the wrong way. So Darwin reigns, the Darwinian axiom of mutation selection explaining everything is the most powerful intellectual paradigm that the human race has ever seen. If you go onto a campus and you go to the sociology department, they begin their teaching sociology from the framework of evolution and how society evolved. And if you go into a psychology department, they're going to tell you about how the psyche evolved. And if you go to the basket weaving department, they're going to try to argue that baskets evolved. It's a universal, in a secular university, it is the mantra that all professors agree to. A lot of disagreement on the campus, but no one disagrees with the Darwinian primary axiomatic belief. What if it was false? If this paradigm was falsified, and I believe it is being falsified, it means the whole world has to rethink everything, which I think is exactly what's needed. Oops. So we've spent 10 years developing the most advanced numerical simulation program that lets us model the mutation selection process. We can adjust the mutation rate, the population size, the selection intensity, the profile of mutational effects. We can dial in any scenario you want and tell you what's going to happen. We can predict whether evolution fitness, whether the population fitness will go up or down, and we can monitor what's happening in terms of mutation accumulation depending on different parameters. And the name of our program is called Mendel's Accountant. It's a good name because we're basically doing accounting. We're keeping a spreadsheet of mutations as they happen in a population and how they accumulate in individuals and how individuals are or aren't selected away. And so it's basically a vast genetic accounting program, and we can track billions of mutations through time. And what we see is when we use anything that's has reasonably realistic parameter settings in terms of population size and mutation rate, etc., we see continuous fitness decline. So here's the fitness of one, meaning a perfectly normal or beginning organism. And basically, deleterious mutations accumulate continuously following a curve like this. Does that curve remind you of anything? Remember the biblical data? This has to do with genetic variants, so don't worry about that. These are some of the parameter settings. In just 200 generations, we see a dramatic decline in fitness using a mutation rate of, actually here we're using a mutation rate of 100, which is approximately the mutation rate for men. And so what we see is this 200 generations is basically the number of generations from Adam to now, if you believe the biblical genealogy. So this is in a biblical time frame from a young Earth point of view. There's the same data from the Bible, measuring in terms of centuries after Noah. So we think that our numerical simulations conclusively show what the other population of geneticists were also understanding. Let's look at the biological data, because all this is theoretical up to now, right? But let's do some biological experiments, or let's look at some biological systems. We wrote a paper in that big fat symposium proceedings, this paper, Information Loss, Potential for Accelerating Natural Genetic Attenuation of RNA Viruses. We were saying sometimes mutation of accumulations might help us slow down bad viruses. And we simulated it, and we showed that, yeah, something like the influenza virus should degenerate over time. And then later, after we wrote that theoretical paper, we studied the history of the influenza virus in the human race. And so this is a paper we published, again, in Theoretical Biology and Medical Modeling, a new look at an old virus, patterns of mutation accumulation in the human, H1N1 influenza virus since 1918. H1N1 is what caused the great flu pandemic that killed 50 to 100 million people. More people died in the time of World War I from this virus than all the people who died in World War I. This was one of the greatest disasters of human history, and it was caused by an RNA virus. So a lot of data was recorded since that time. So first, we were able to get hold of all the sequence. See, people were freezing the RNA since the 30s, and people dug up the original RNA strain, which was a bad idea. And so we know the sequence of the original virus, and we can see mutations accumulate over time. And what we see is that the virus, the human H1N1 virus, mutation count, you can extrapolate back to when the virus first emerged. But here, starting from the 30s, when we had our earliest sequence data, the number of mutations above and beyond the original strain just increased perfectly linearly. And the number of protein-changing mutations also increased linearly. This is exactly what all our simulations show. Mutations accumulate in a clockwork way. Just like clockwork, mutations keep accumulating. And you can only select away less than 10% of them. The rest accumulate like rust in a car. So we see evidence of genetic degeneration in the influenza virus. And here's a paper by people who studied the virulence of the influenza virus. This is the amount of excess death that's attributable to the influenza virus starting back in the 20s, or maybe in 1918. Can't tell if that lines up. This is not our data, this is from another paper. But they show that mortality declined